Hi guys, hope you had a good turkey day. I did. I've been getting a couple of emails with questions about the astronomy project, so I thought I'd give you a quick clarification video. So first of all, there are two scales to keep in mind, and I don't know if you can read it. There you go. For the globe, we're going to be at a 1 in 10 to the 8th scale. So that's 1 in 100 million. For the sign, you're going to be at a 1 in 10 billion scale, 1 in 10 to the 10. So what we're going to do is take your planet and shrink it down so it's a lot easier to kind of picture. If you're making a globe, all you need to do is find the size of the globe, the size of your planet, divide it by 10 to the 8th, and you'll have the new size. If you're going to make a globe that's that size, if it's going to be bigger than a meter tall, you do not need to make it 3 dimensions. So in that case, you can just take paper and make a two-dimensional cutout. If you have something that's going to be, say, like 2 meters big, I mean, that's huge. You'll probably need to use maybe a roll of paper in the maker space or something along those lines. If you start using printer paper, you're going to have to attach a whole bunch of sheets in order to get something big enough. Or you could do something creative like get a sheet and cut it out. That would be easy too. If you're doing the sign, you're going to be working on a 10 billion scale. And I put a little asterisk on the original description because I said we probably would be doing it different. In the email I just sent out, I tried to clarify, but people still had questions. So what you're going to do here is shrink the whole thing down by 1/10 billionth, and instead of having a picture of your planet, you're going to have a two-dimensional, so paper, cutout of your star. So if you're Kepler 11b, then this star is Kepler 11. So you're going to take the size of your star, divide it by 10 to the 10, and get a sheet of paper. Well, the whole point, though, for the sign part is to show how far things are. So at this same scale, we want to give an idea of how far your planet is. Now, most of your planets on this scale would be a teeny tiny little speck that you'll never see. So because it's going to be really hard to show that speck, instead what we're going to do is take a thin strip of paper. It doesn't have to be big. It could be 1 inch thick or 2 inches thick. But a small strip of paper, and attach it to the star so that it stretches out and shows you how far away it is. The end result, let's see if you can, there you go. The end result is going to be like a big lollipop. So there's your star, and then all the way out here you'll have a little dot, and write the name of your planet and say, hey, here's my planet here. Along the way, you're going to write a little note saying how long this distance is, and give a good idea for how long it takes them to get there, or some way of picturing it. So you could say, hey, this would be like 10 billion baseball fields or football fields. For Earth, for instance, if you were walking the average walking speed of a person, 3.1 miles per hour, to walk from the Earth to the Sun would take you, if you're walking nonstop, 3,413 years. So I'm going to do Earth. So I'm going to have a scaled down sun. That's going to be about 14 centimeters, so about this big. I'll get a little circle cut out. And then I'm going to have a strip of paper that is 15 meters long. So it's going to go almost the entire length of the hallway, and that's where this is going to live. And at the end of that 15-meter long strip, I'm going to have a little dot that says Earth. And then along the way, I'll say, hey, if you were walking, average walking speed, this would take you 3,413 years. Hope that clarifies. It's not due the moment we get back, so you have a little bit of wiggle time when we get back from break. If you have questions, email me, but hopefully this helps. Bye now.